Hi, I hope everyone is doing well. In this video, I am going to define what a complex number is, briefly explain how important it is in the context of electrical engineering, and solve some of the basic operations on complex numbers. Now, why do we need to study complex numbers? Because as engineers, it serves as our most basic tool in dealing with engineering problems, especially in our major courses like AC circuits, transmission and distribution, and power system analysis. Now, later on, when we come across circuits such as this one or this one, every single mathematical tool that these circuits need pretty much involve a ton of complex numbers as their solution. So to formally begin our discussion, let us define what a complex number is. A complex number is any number of the form a plus bi, where a is called the real part and b is called the imaginary part. The I there is called the imaginary unit, or a number that is equal to square root of -1. Now in electrical engineering, we change the notation. Instead of writing your complex number in a plus bi form, we write that in terms of a plus jb, where the j is written in front of the imaginary part and is still equal to square root of -1. Because the letter I in electrical engineering stands for current. A complex number can be written in four ways, and each of these forms has its own application as far as the EE problems are concerned. The first one is called the rectangular form. This is the most widely used notation of a complex number in the form of a plus jb or a plus minus jb, while the second one is called the polar form. The polar form of a complex number is given by the formula r angle plus minus theta. The angle theta must be expressed in terms of degrees. These two forms can be related with each other as shown in the complex plane, where the horizontal axis represents the real number and the vertical axis represents the imaginary number of a rectangular complex number. The polar form actually represents the hypotenuse of the right triangle formed by the real and imaginary parts and the direction of r, which is represented by the angle theta. The third form is what we call the trigonometric form. This form can be easily obtained once the polar form of the given complex number is already present. And the last one is called the exponential form. It is given by the formula r exponential plus and minus j theta. That angle theta must now be expressed in radian. For example, let us convert this complex number z equal to 3 plus j4 into its equivalent polar form, trigonometric form, and exponential form. Using our calculator, press Shift 2 and 3 to convert 3 plus j4 to polar form. We set our calculator to complex mode. Press mode, press 2 for complex, and type 3 plus 4i, press equal sign. Convert this number into polar, press Shift 2 and 3 and then press equals. Our answer is equal to 5 angle 53.13 degrees. If you happen to have one of those FX9N1EX type of calculators such as this one, after setting the calcute to complex mode by pressing menu and choosing option 2, to convert 3 plus 4i to polar, what you want to do is you're going to click option and then click down arrow and choose option 1 to select r angle theta to obtain the same answers before, that is equal to 5 angle 53.13 degrees. And for letter B, use the formula for trigonometric form. Our final answer should be equal to 5 quantity cosine 53.13 degrees plus j sine 53.13 degrees. For the exponential form, we need to convert 53.13 degrees into its equivalent radian angle so that your final answer should be 5 exponential positive j 0.9273. To convert 53.13 degrees into radian, multiply 53.13 times pi over 180. It should give us 0.9273 as our radian equivalent of 53.13 degrees. And these are our final answers. Now we proceed to algebraic operations on complex numbers. That is addition, subtraction, multiplication, and division. Suppose we have two complex numbers, z1 and z2 in rectangular form with their corresponding polar forms. If you want to add two complex numbers, z1 plus z2, just simply add the real parts and the imaginary parts. For subtraction, z1 minus z2 is equal to the difference between the real parts and the difference between the imaginary parts. For multiplication and division, however, we need to make use of their respective polar polar forms in order to multiply and divide two complex numbers. And it shows that addition and subtraction are better performed in rectangular forms, while multiplication and division are better performed in polar forms. What is a complex conjugate? Given a complex number z equals a plus jb, its equivalent complex conjugate in the form of z asterisk is equal to a minus jb. Just simply change the sign of the imaginary part. And it also follows for polar form, if you have r angle theta, its equivalent complex conjugate should be r angle negative theta. For trigo, positive and negative, and for exponential, that's r exponential j theta, complex conjugate is equal to r exponential negative j theta. Also, we note that from trigo form, wherein we have the formula z equals r quantity cosine theta plus j sine theta, some books actually write it in this form. That's z equals r cjs theta, or is also equal to r cis theta. Therefore, from our previous example, wherein we had a final answer of 5 quantity cosine 53.13 plus j sine 53.13, an alternate notation can also be written in the form of 5 cis 53.13 degrees or 5 cjs 53.13 degrees. Now let us try to solve this second example. Given z1 equals 3 plus j4, a complex number z2 which is equal to 4 minus j3, determine the following. Though we can use the previously discussed formulas for addition, subtraction, multiplication, and division, let us use our calculator to simplify our solution. For letter A, z1 plus z2, we have 3 plus 4i plus 4 minus 3i. Final answer should be equal to 7 plus I or 7 plus j. For letter B, z1 minus z2, that's 3 plus 4i minus quantity 4 minus 3i equals negative 1 plus j7. For letter C, just simply multiply the two complex numbers without really using the formula so that it becomes 3 plus 4i multiplied by 4 minus 3i. Your final answer should be equal to 24 plus j7. Letter D, z1 divided by z2, divide 3 plus 4i divided by 4 minus 3i. And the answer for letter D is just equal to j. Letter E, the equivalent complex conjugate of the complex number z2 is just equal to 4 plus j3. We can use our calculator to solve for the complex conjugate of a given complex number. Type 4 minus 3i, press equal sign, press shift 2, and then press option 2 for conjugate. Conjugate of answer in close and then press equal sign. The conjugate of 4 minus j3 is just equal to 4 plus j3.